Google is erecting 2 new buildings in Mountain View, California, and they have a very unique, if not scaly, design. Instead of your standard shingle, the roof has a Dragonscale solar skin. It consists of 90,000 3-foot by 5-foot silver solar panels that can generate about 7 megawatts of energy. The roof is part of the company's effort to operate carbon-free by 2030. Google partnered with Swiss company SunStyle, which created the highly textured prismatic glass shingles. According to Google, prismatic glass can, quote, trap light that eludes traditional flat solar panels. They are also covered in an anti-glare coating to make them less reflective, which means less glare problems for drivers and pilots. The unique curvature of the roof that kind of looks like an over-the-top circus tent will optimize the amount of time the Dragonscale cells will generate power. Once it's completed, the roofs will generate about 40% of the building's energy needs. The panels were designed in a standard size with standard mounts to be more manufacturable. According to a report from Grist, SunStyle has installed similar arrays on some 500 roofs in Europe, but only 2 in the US, some bank in Illinois and an architect's home in New York. The company now has plans to launch more affordable Dragonscales targeted to homeowners looking to replace or install a new roof. The roof with Dragonscales should run about the same as a new roof with solar panels. However, Dragonscales can also cover eaves and ridges and just sound cooler. Last week, DARPA selected 10 teams to work on its Enhanced Night Vision in Eyeglass Form, or Envision, program. The idea is to create a pair of night vision glasses that are the same size and weight as regular eyeglasses. Night vision systems are bulky and can weigh heavily on a soldier's neck. Over time, it can lead to chronic injuries. They don't just want to make them lighter, but also give them a wider field of view, as well as the ability to use infrared bands to see through obstacles. The teams are a mix of eyewear companies, Department of Defense staples like Raytheon and Physical Sciences, and universities. We've mentioned before how robots could be used in remote and hazardous environments that are challenging, if not impossible, for humans to traverse, like looking for survivors after a natural disaster or industrial accident. While previous tech has been promising, one of the biggest obstacles has been the robot's ability to quickly assess and navigate the terrain. One problem is how the robots see the ground and adjust their gait to remain upright and stable. For example, robots have trouble walking through snow, vegetation, or water because they are highly reflective surfaces, and the robot doesn't know what it's stepping on or the true height of the ground. They also struggle with depth perception in foggy, dusty, and dimly lit areas. And if they're going to be useful after a disaster, they're going to be in some dusty and dimly lit areas. Until now, a robot had to step down and feel the terrain before adjusting its gait, which really slowed it down. Well, a team of researchers at ETH Zurich in Switzerland have come up with a solution. They created a new perceptive locomotion controller and strapped it to an ANYmal, which, for better or worse, is often referred to as a robot dog. Then, they tested this robot dog in multiple scenarios that would have forced other dogs to stay. Perhaps the most impressive was walking through high snow, but the ANYmal also climbed stairs in foggy conditions, successfully completed hiking paths without falls or human intervention, and was even used to study monkey-robot interaction in South Africa. The importance of robot-animal interaction aside, the robot performed each of these environments using the same settings and didn't experience a single failure. The locomotion controller was also used by Team Cerberus for DARPA's Subterranean Challenge. It operated autonomously underground without a single fall and helped the team net $2 million in prize money. And like many a robot before it, and many to come, they had to test it for human intervention. So, they tried to throw it off course by pushing it and then dragging it on a leash. It's funny and cruel, like in a robot feeling sort of way, but it's also remarkable that ANYmal stays on its feet. I'm David Manti. This is Engineering by Design.